Bismillah ar-Rahman ar-Rahim. This is problem 212 in your book. And Florida Advanced Wastewater Treatment Standard. This is the standard by the Protection Agency in the US. Require that treated effluent has no more than 5 ppm BOD5. Of course, we will study BOD5 once we come to wastewater treatment and the water quality later on in class. So the standard that the treated effluent, that this what comes off the treatment plant after treatment, the BOD5 should not be higher than 5 ppm. Also, TSS, total suspended solid, should not be higher than 5 ppm. Total nitrogen, TN, total nitrogen, should not be higher than 3 ppm, 3 part per million. Okay. And also the last, total phosphorus should not be higher than 1 part per million, 1 ppm. Well, this is the standard that's being issued in Florida, and they are following the very strict standard for wastewater treatment effluent. Number one, or the problem it's asking for, what is the wastewater standard for TN and TP in milligram per liter? Remember, if you have pollutant in water, and he needs TN in milligram per liter, he needs the TN standard. You know that in water, ppm is equivalent to milligram per liter. So we don't have to do any conversion. You could just try it. You could look at the note and look at how to convert this ppm to milligram per liter. But ppm and milligram per liter are equal only for water. So the total nitrogen standard in milligram per liter is 3 milligram, of course, milligram nitrogen per liter. And also they want total phosphorus. The total phosphorus standard is 1 milligram phosphorus per liter. So we solved the first one. Now let's go to the second one. If all nitrogen is transformed to nitrate, okay, during the advanced treatment, what is the effluent limit of nitrate in milligram per liter? Okay, let's go first of all and find the total nitrogen. He's saying that all the nitrogen is transferred to nitrate. So nitrate, this is NO3 minus. Okay, so let's look at the total nitrogen, which is 3 milligram per liter nitrogen. Let's convert this to mole. So you know that it is, if you divide by the molecular weight, and the molecular weight of nitrogen is 14 gram per mole. Of course, it's mole of nitrogen, and this is gram of nitrogen. But you have to convert gram nitrogen to milligram nitrogen. 1 gram is 1,000 milligram, so you'll end up with milligram nitrogen with milligram nitrogen, gram nitrogen with gram nitrogen. You'll end up with mole nitrogen per liter. Remember that if you have NO3 and it is going from N to NO3, so 1 mole of nitrogen will give you 1 mole of NO3. Okay, so you could convert the mole of nitrogen. You put it down and you put mole of nitrate. mole of nitrate. 1 mole will give you 1 mole. Look, you see, 1 mole will give you 1 mole. So now mole nitrogen cancelled with mole nitrogen, you'll end up with mole NO3 minus. And now you convert the mole of NO3 to gram or milligram. So NO3, the molecular weight is 62. So you have to do the molecular weight of oxygen and nitrogen. You remember nitrogen is 14. And you know that the oxygen is 16, but this time you have 16 times 3. So 16 times 3, if you do it, 16 plus 16, 32, plus 16, 8, 84, 48, plus 14, 12, and this is 62. So this is 62 gram of NO3 over mole of NO3 minus. So you have this, you could cancel mole NO3 with mole NO3, you'll end up with gram. Now you convert gram to milligram. Gram NO3 to milligram of NO3. You know that 1 gram is equal to 1,000 grams, so gram with gram. So you end up with, and you can see that the 1,000 cancel with the 1,000, you'll end up with the following 3 divided by 14, if you go all the way, times 62, and that's it. So if you do that, you'll end up with 13 milligram NO3 minus per liter. So if all nitrogen is transformed, if the all nitrogen transformed to nitrate, then the effluent limit of nitrate becomes, because this is the total nitrogen standard, 3 milligram per liter, the effluent nitrate should not be higher than 13 milligram per liter of nitrate. Let's look at the other one. If your laboratory had obtained and processed 200 mils, so you went to the lab, you took a volume of 200 milliliter sample of treated wastewater for TSS test. So you want to do total suspended solids. How many milligrams of suspended solids were captured on the filter for the sample? Remember from the end of the chapter 2, you could determine that the standard should not be higher than 5 ppm, which is let's say 5 ppm, and that is the standard. That's the effluent, should be not go higher than this, which is equivalent to 5 milligram of TSS per liter. Now he's saying here that he wants to process 200 milliliter sample. So let's do that. Let's multiply it by 200 milliliter sample. And of course, you need to convert milliliter to liter. So milliliter, liter. You know that 1 liter is 1,000 milliliter. So mil with mil, liter with liter. You'll end up with, let's say, the 205 times 200 divided by 1,000. And you can see 2 zeros with 2 zeros. And then this is in milligram TSS. And then you'll have 5 times 2, 10. 10 over 10 is 1. So it is 1 milligram. 1 milligram. The answer is 1 milligram total suspended solids.